Hello learners. Today let us see about the performance parameter measurement of BMS. So the first parameter is cell voltage. The BMS continuously measures the voltage of every individual battery cell using a voltage sensing integrated circuit. Cell voltage is one of the most important parameters because over voltage can damage the battery and under voltage can permanently reduce battery life. The next parameter is pack voltage, which is simply the sum of all individual cell voltages. This value indicates the total voltage available from the battery pack and is used to estimate battery performance. The battery current measures the charging and discharging flowing through the battery. It is measured using either a Hall effect current sensor or a shunt resistor. Current measurement is essential for calculating battery capacity and protecting the battery from overcurrent conditions. So, power is nothing but the pack voltage into pack current. And let us see the thermal parameters. Before that, the internal resistance and the insulation resistance plays vital role in deciding the battery performance. So, insulation resistance measures the electrical isolation between the high voltage battery and the vehicle chassis. And whereas the internal resistance is calculated from the change in voltage divided by the change in current during pulse testing. A higher internal resistance indicates battery aging and causes more heat generation. Next one is thermal parameter. So in thermal parameter, the cell temperature, which decides the overall pack temperature, which is the average temperature of all cells. So the maximum temperature and minimum temperature help identify the hottest and coldest cells inside the battery pack. Then next one is the temperature gradient. This is the difference between maximum and minimum temperature values, and a high temperature gradient indicates uneven cooling and poor thermal balance, which can reduce battery life. So with this, thermal parameter is over. Now next one is energy parameter. So SOC, which is the first parameter, state of charge, it indicates the remaining battery capacity in percentage, similar to the battery indicator on a mobile phone. Then depth of discharge, DOD, represents the amount of battery capacity already used. It is simply equal to 100 minus the state of charge. Then energy consumption, which is obtained by integrating power over the time. It tells us how much electrical energy has been consumed during the operation. The next one is useful energy, remaining useful energy, which estimates how much energy is still available in the battery based on the current SOC. Then Coulomb counted capacity, which is calculated by integrating the battery current over time. This method is widely used by BMS to estimate battery capacity accurately. Then let us move on to the health parameters, fourth one. First one is SOH, state of health, which indicates the present condition of the battery compared to a new battery. A battery with 100% SOH is considered new, while lower values indicate aging. Then capacity fade, which measures the reduction in maximum power output due to battery degradation. Then cycle count, which records the number of complete charge and discharge cycles completed by the battery. The remaining useful life, or RUL, which predicts how long the battery can continue operating before replacement is required. Modern BMS systems estimate this using AI algorithms and machine learning techniques. Then next one is the performance parameters, and in which the first one is SOP, state of power. State of power means which is the maximum available charge and discharge power. So the formula is given here, which depends on the value depends upon the SOC, SOH, and the temperature limits. Then charge efficiency, discharge efficiency, round trip efficiency, for all these parameters, the formula is given here, and actual description is mentioned here for the each and every performance parameters, in which the power delivery capability is considered to be very most important, which is defined as maximum allowable discharge power, also which is based on SOC, temperature, SOH, and cell voltage. The next one is safety and protection parameter, which includes over voltage of the cell. So if the cell voltage exceeds the prescribed limit, then it is considered to be over voltage. And similar for under voltage, the value range of the value is 2.8 to 3 volt. So if under voltage happens, the charging process will be, sorry, discharging process will be stopped. In case of over voltage, charging process will be getting stopped. So in case of pack over voltage, the similar operation will be happen, uh, which if the limit exceeds the prescribed value, and it will be called as over voltage. And for under voltage, the pack voltage will become lower than the prescribed value. And for over current, that is for charging current, if it exceeds the limit, then stops the charging. For over current during discharging, then reduce the discharge, that is the load is disconnected from the battery. If the short circuit detected, then the contactor will be getting open to avoid any damages to the battery and load sides. Then over and under temperatures, due to internal operations of the battery, the over temperature causes, and operation will be stopped. For under temperature, charging, if the temperature limit is below, then charging will be stopped, and the discharge, allowable discharge is limited to the safe value. If insulation fault happens, then contactor gets open, and for ground fault, the same process will be done, that is the contactor or alarm uh, circuit will be switched on. So this is all about the parameters of the battery pack, and this is very useful in design of BMS. Thank you.